Hi, welcome to G-Block's Stats class presentation of independent and dependent events by Brett and Sam.
Here we'll explain the addition and multiplication rules of independent and dependent events. First, we'll look at the multiplication rule of probability of dependent events, which can be found on page 348.
For this example, we'll use a deck of cards. What is the probability of drawing 2 aces in a row? If there are 4 aces out of 52 cards, and you happen to pick one row, there are 3 aces out of 51 cards in the deck. This is the example.
Now, to find the probability, you multiply 4 divided by 52 times 3 divided by 51, which gives you 0.00452. This means you have less than 1% chance of drawing 2 aces in a row.
This is very similar to the multiplication rule for independent events, except to be independent in this example, you must replace the first ace drawn. This rule is on page 331 of your textbook.
Next, we'll look at the M&Ms to help explain the addition rule of independent events. Say 25% of M&Ms are blue and 25% are brown. What is the probability of picking either blue or brown?
This is easy.
Just add the probability of both. 25% plus 25% is 50%. Chance of picking one or the other.
Addition rules like this are why you choose one or the other. Multiplication rules pertain to AND problems.
The next rule is a little trickier. The addition rule of dependent events, found on page 343, is probably the most difficult of the 4. The rule deals with the probability of events that can occur separately or at once. Take, for example, A and B can happen separately or together.
To figure out the probability of both happening, you must add the two probabilities and subtract out the overlap. A if the probability of B.
Now it's your turn. Use the first rule we went over, the multiplication rule of dependent events, to find out the probability of drawing 3 aces in a row.